Hello students, welcome to Learner's Planet, Theory Session 4 of Metals and Non-Metals. In our previous session, we discussed the physical and chemical properties of metals, reaction of metals with oxygen, about the nature of their oxides, and also about their reaction with salts. We also discussed about the reactivity series. Now, what is a reactivity series, children? In the reactivity series, the metals are arranged according to the decreasing order of their reactivities. And I also told you that the metals lying below hydrogen in the reactivity series can displace the metals lying above hydrogen in the reactivity series can displace the metals lying below hydrogen in the reactivity series from their salts. That is, the metals which are present above in the reactivity series are reactive, and those present below hydrogen in the reactivity series are less reactive. Here we are going to discuss reaction of metals with metal oxides. Right? Now in this case, children, a more reactive metal will displace a less reactive metal from its oxide, meaning metals lying above hydrogen like sodium, like potassium, like aluminium, calcium, iron, zinc, they are lying above in the reactivity series, above hydrogen. Now those lying below hydrogen in the reactivity series are, what are those metals below hydrogen? What are those metals, children? They are mercury, silver, gold and copper, of course. So these are the metals which are lying below hydrogen in the reactivity series. Now what is my point is, children, that a more reactive metal will displace a less reactive metal from its oxide. That is, metal A plus oxide of B. What will be the product? Oxide of A plus metal B. So which is more reactive, children? A is more reactive. Now let's take up its examples. Reaction between magnesium and copper oxide. So in the reactivity series, magnesium is placed above hydrogen and copper is placed below hydrogen, or copper occupies a lower position in the reactivity series. Now since magnesium is more reactive than copper, it should be than copper, it will displace copper from copper oxide and forms what? Magnesium oxide. So it is forming what? It is forming magnesium oxide. So your copper oxide plus magnesium will give what? Magnesium oxide plus copper solid. Similarly, sodium. Sodium is again a reactive metal. Now this will also react with copper oxide, forming sodium oxide and copper solid. Now I can take any non-unreactive metal. For example, I can also write here that there is an oxide of zinc and it is reacting with a very reactive metal, that is potassium. And then what will be the products formed, children? The products formed will be what? Which is more reactive? Potassium. So potassium will displace zinc from zinc oxide and it will form potassium oxide plus zinc solid. Likewise, I can take here aluminium also with copper oxide or iron oxide. We did this reaction in chemical equations and reactions, that is Fe2O3 with aluminium. Now here children, which is lying above hydrogen in the reactivity series? Aluminium. And which is lying below? It's iron. So what will be more reactive? Aluminium. Now what I'll get the product? I'll get Al2O3 plus of twice of Fe. So those metals which occupy a higher position in the reactivity series are reactive, whereas the lower ones are less reactive. Now let's take some other reactions like reaction of metals with acids. Metals react with acids, forming their salts and liberating hydrogen gas. For example, magnesium reacts with concentrated sulfuric acid, forming what? Magnesium sulfate and hydrogen gas. Here children, calcium solid reacts with hydrochloric acid, forming calcium chloride and hydrogen gas. Now there is one point which I would like to discuss here. Why and how this hydrogen gas is liberated? Now we know children that hydrogen in acids is present as H plus ion, or I can say that acids dissociate and give what? H plus ion, right children? Now when this H plus has to be evolved as hydrogen gas, what should it take up? Like this H plus will take up 2 electrons and it will be evolved out as hydrogen gas. So what is given out is hydrogen gas. So what is essential? The essential part here is the electrons which are given by metals. We know that metals form electropositive ions. How? By releasing electrons. For example, magnesium here. Your magnesium forms what type of ion? It forms Mg2 plus ions. Mg2 plus ions. And what is it liberating children? It is giving out 2 electrons. Now these 2 electrons are accepted by H ions given by sulfuric acid, so that your hydrogen is released out as hydrogen gas. Now here there is reaction with nitric acid. When a metal reacts with nitric acid, it can be dilute or it can be concentrated. Hydrogen gas is not evolved. Now what is the reason behind this? What I told you was that metals give out electrons, forming electropositive ions. So what happens? That those electrons are accepted by hydrogen ion and hydrogen is thus evolved as hydrogen gas. But in this case of nitric acid children, nitric acid is a strong oxidizing agent. What do you mean by an oxidizing agent? That it oxidizes. It gives out oxygen. So, as soon as hydrogen gas is formed, it gets oxidized to water. Now here there is an example of magnesium with very dilute, that is very dilute nitric acid. When this is the case, then only hydrogen gas is evolved. Otherwise, if it's dilute or concentrated, hydrogen gas is not evolved, and what is formed here is water. Let's take up few more reactions of this. Reaction of copper with dilute nitric acid. It will form copper nitrate or cuprous nitrate, or I can also write here as copper 2 nitrate. So, and what all is formed? NO, that is nitrogen monoxide, and water. Now why this NO is formed? What happens, children, that nitric acid is what? It is an oxidizing agent. Now as it is an oxidizing agent, it will oxidize your hydrogen to water, and it itself will get reduced to NO or NO2. So HNO3 is reduced to NO, either it also forms N2O or NO or NO2, depending on the concentration of nitric acid. Now here what all are the things formed? Here we have got nitrogen monoxide and H2O. That is, your nitric acid has been reduced to nitrogen monoxide and hydrogen is oxidized to water. Now in this case, this is a concentrated nitric acid. Now the salt formed is the same, that is copper 2 nitrate, and nitric acid is reduced to nitrogen dioxide and hydrogen is oxidized to water. So children, you can take any metal like lead or iron, right? These all react with nitric acid, giving their respective nitrates plus NO with dilute one, NO2 with concentrated, and N2O with very dilute. That is your zinc. Zinc gives all the three depending on the concentration. Now let's move to the reaction of metals with halogen. Now what are the elements which are called halogens? Halogens, these are the elements which are present in the 7th group of the periodic table. And what are these elements? These elements are fluorine, chlorine, they all exist as diatomic molecule, fluorine, chlorine, bromine, iodine, and the last one is astatine, which is a radioactive element. Now these elements are called as halogens. They are highly reactive elements. Why? Because they have got 7 electrons in their valence shell. So as they have got 7 electrons in their valence shell, how many electrons they require to complete their octet? They require only 1 electron. So these are highly reactive elements, so they exist as diatomic molecules. Now in this case, metals react with chlorine. What will they form? Like calcium reacts with chlorine, forming what? Calcium chloride solid. Sodium reacts with chlorine, forming what? Sodium chloride. Likewise, magnesium will react with chlorine, forming what? Magnesium chloride. So down the group their reactivity decreases. Whose reactivity? Down the group the reactivity of halogens decreases. So which will be least reactive? Iodine. Then bromine, then chlorine, and fluorine would be highly reactive. So this is your reaction with halogens. Now these were all the properties of metals. Now let's move to non-metals, that is physical properties of non-metals. Their physical state, they exist in solid, liquid and gaseous state. That is, they are existing in all the three states, right? Example: carbon, sulfur, phosphorus are what? They are solids. Your bromine is a liquid. Hydrogen, oxygen, nitrogen, all are what, children? They are gases. Now do you know how sulfur exists? Sulfur exists as SH molecule. Phosphorus exists as P4 molecule. Or your oxygen, it is a gas. So these exist as SH or P4 molecules, and they are solids. Let's take up its next property. Density. Non-metals have low densities. That is, they are light substances. Density is what? It is the ratio of mass to volume. Okay? So, they are light substances means very small amount of mass is present in huge volume. Okay? Now, melting point and boiling point. They have low melting and boiling points. Why, children? Melting and boiling point is straight away related to the intermolecular forces of attraction. In case of metals, they are solids, and intermolecular forces of attraction is very, very high. Okay? Whereas non-metals, these are what? These are either gaseous state or in liquid state. So the intermolecular forces of attraction is less here. If I take example of iodine, which is a solid, still it has low melting point than metals. Because in metals, apart from intermolecular forces of attraction, strong metallic bonds are also present, right? Whereas in non-metals, those metallic bonds are not present, only intermolecular forces of attraction are there, right? Now in this case, what is the exception here? Diamond has a very high melting and boiling point. Its melting point is more than 3500 degrees centigrades. Right? What were the exception in metals? We discussed that metals have very high melting point, but there are some exceptions like cesium, like gallium. They start melting in hand. Their melting point is 32 and 28. So there are exceptions everywhere. Now let's take up the next physical property, that is hardness. Non-metals are generally soft. We all know they are gases, either liquids or solids. Even if they are solids, they are soft because a strong bond is not present there. What is present there is just the intermolecular forces of attraction, or the van der Waals forces of attraction. Now here, children, what is the exception again? Exception is carbon in the form of diamond is a non-metal which is extremely hard. So this is the only non-metal which is extremely hard. While discussing the bonding topic, we will discuss what type of bond is present between carbon atoms, or I'll tell you here only. In diamond, the carbon atoms are arranged tetrahedrally. I'll just show you the tetrahedral arrangement here. It is on the center one, there is one line. So there are 4 carbon atoms, and these are joined by the tetrahedral arrangement, drawn like this. Okay, so this is your carbon structure, or the structure of diamond. There are 1, 2, 3, 4 carbon atoms, and what type of bond is here, children? The bond between carbon atom is a covalent bond. and it's a very strong bond. That is why diamond is the only non-metal which is extremely hard. Malleability and ductility. They are neither malleable nor ductile. Right? You can't make ornaments or foils out of non-metals, even if it is solid. Then electrical conductivity. Non-metals do not conduct electricity. And when we were discussing the physical properties of metals, I have told you that metals conduct electricity because they have free electrons. They have either 1 or 2 or maximum 3 electrons in their valence shell. Whereas non-metals, they have 4 or 5 or 6 electrons in their valence shell. Am I clear? Or even 7. So they are not that free. So they do not conduct electricity. Now here also children, the only exception is carbon non-metal in the form of graphite conducts electricity. Now graphite has a structure such that it has got one lone pair of electron. If I'll draw the structure of graphite, I'll draw a rough structure of graphite. In this, the carbon atoms are present in layers. These layers they are present, and they are bonded in such a way that there are free electrons with every carbon atom. There is one free electron, and that free electron moves between the layers, and in such a manner graphite is a good conductor of electricity. Right? And because of this, graphite is soft also. Now next, let's move to the next property of non-metals, that is luster. L-U-S-T-U-R-E it should be. Non-metals do not have luster. Luster, or it is the shine on the surface. As the metals, they have got shiny surface. Why? Because of the presence of this free electrons. These free electrons gain energy, get excited to the higher energy state, and when they come back, they lose that amount of energy. So they have got a shiny surface. Whereas non-metals, they have got large amount of electrons in their valence shell. That is either 4 or 5 or 6. So they are not free. So they have dull surface. But here there is again an exception. What is it? Iodine. It has a shining surface. Right? So this is an exception here. Now our next property is electronic configuration. They usually have 4, 5, 6 or 7 electrons in their valence shell. Like sulfur. The atomic number is 16. How can I arrange these electrons? I can arrange them as 2, 8, 6. Right? So how many electrons it is having in the outermost shell? 6. How many electrons it requires to complete its octet? 2. So what type of ions it will form? It will form electronegative ions, or the negative ions. Or sulfur is electronegative. Likewise silicon. Silicon, the atomic number is 14. What will be its electronic configuration, children? It would be 2, 10 and 4. Now this can't form iron. It forms ions only under drastic conditions, that is very high temperature. So it can't form iron actually. So what type of compounds it will form? It will form covalent compounds. Under drastic conditions it can form a negative ion. Now phosphorus, what is the atomic number? It's 15. What would be its electronic configuration? 2, 8 and 5. So, how many electrons it requires to complete its octet? It requires 3 electrons. So, will it form an electropositive ion or a negative ion? It will form a negative ion. And what is the name of its negative ion? Phosphide. So, P3 minus the name is phosphide. F2 minus is what, children? It is sulfide. Now let's take up some of its chemical properties, like ionization. They always ionize by gaining electrons. So they gain electrons and they form their respective ions. Charge on ions. Now as they are gaining electrons, what charge they'll acquire? They'll acquire negative charge. So what type of ions they form? They form negative ions. Like your chloride gas, Cl exists as Cl2, and it will form what, children? It will form chloride ion, or I can write here 2Cl minus. And similarly sulfur will take up 2 electrons and it will form sulfide ion. Any other ion, say nitrogen, N2. How many electrons it should take up? How many electrons are present in its valence shell? It's 5. How many electrons it requires to complete its octet? 3. So it will take up 3 electrons and will form what? It will form N3 minus ion, twice of N3 minus ion. And what is this N3 minus? It is nitride ion. What type of ion is this, children? It is nitride. In very few compounds it exists as nitride ion, like urine 3H, right, hydrazide. So these are the properties of non-metals. They form negative ions. Metals form positive ions. Now for this session I'll conclude, and in our next session we will be discussing the chemical properties of non-metals.